ng sa seismic wave, yung makikita nyo yun sa orange, ito po yun. Tapos, in addition lang, ang seismic wave kasi, ito lang ang focus ng aming discussion kasi nung ano naman, nung mga senior high or nung high school, na-discuss na naman natin ang iba't ibang uri ng waves, di ba? Ang sound waves, electromagnetic waves. Pero ang focus lang natin, since earthquake nga, seismic wave lang. Pag sinabi kasing seismic wave, nangyayari sa surface ng Earth.
Amplitude, the maximum displacement or a point of wave from its rest position. Ito yung maximum height above or below the mean position.
Ito po yung amplitude nasa gilid.
Epicenter, the point directly above it at the surface of the Earth. Hypocenter, the point within the Earth where an earthquake rupture starts. Ang hypocenter at epicenter ay ginagamit natin upang malaman ang lokasyon at pinagmulan ng earthquake. Sa hypocenter, sinasabi na sa point na to nagsisimula ang paggalaw ng fault o nagsasani ng earthquake. Tinatawag din itong focus. Ang epicenter, ito naman yung nagsisilbing map location ng earthquake sa ibabaw o surface.
In addition lang sa epicenter and hypocenter, they differ in three characteristics. First is the position on Earth, second is the associated waves and dimensionality. When it comes to epicenter, ito ay nangyayari sa surface ng Earth, ang hypocenter, subsurface. And when it comes to associated waves, ang epicenter, body waves and surface waves since nasa ibabaw siya. Tapos ang hypocenter, body waves lang. Nasa ano kasi, lalim. Tapos ang dimensionality, two dimension ang ang epicenter and epicenter and hypocenter ay three dimensional.
Attenuation, decrease in the amplitude of a wave with distance. Um, so the smaller the wave, the farther it goes. So isipin na lang natin na may earthquake, assuming na lahat ng locations matatamaan having epicenter as the most shaking part. So kapag lumayo sa epicenter, meaning there is less shaking and may tendency na maramdaman din ito ng mga tao.
Ito yung sa attenuation na tinutukoy. Ang attenuation na tinutukoy dito, yung pagliit kumbaga ng ng amplitude ng sound waves or ng seismic waves from low, 'di ba pagka nasa center yung movement, palaki ang niya, ang amplitude niya. Pa-decrease naman ang sa attenuation dahil dito na-identify yung yung possibility ng ground motion. Wait lang po. Yang para mas malinawan kayo dun sa sinasabing attenuation, ito yung video. Ito lang siya, ayun dito, kung mapapansin nyo.
Wala yata na-present.
Wala po ba? Ito yung sa attenuation. Ito, from station 1 to station 2 and etc. Next is factors of attenuation.
Geometric spreading. Seismic wave amplitude vary as they travel across the Earth. As the wavefront moves out from the source, the initial energy release in the seismic wave is spreading over an increasing area, and therefore the intensity of the wave decreases with distance, the case of geometric spreading. Spherical spreading describes the decrease in the level when a sound wave propagates away from the sound uniformly in all directions. This situation occurs for a sound source of mid-depth in the ocean, for example. One can picture the crest and trough of the sound waves as the spheres centered on the sound location. Ito naman yung energy spreading out in three-dimension even to the ground or to the earth. Na kung saan yung energy is kumakalat patungo sa malaking malaking lugar pag laki ng area pagbaba ng amplitude.
In addition lang dito sa geometric spreading. Technically, ang geometric spreading kasi composes of two. Una ay spherical spreading, ang sunod ay cylindrical spreading. Ang focus lang namin, ang pinagkaiba naman ng ng spherical sa cylindrical. Ang spherical, uniformly ang kanyang yung pagdi-distribute ng mga ng amplitude. Tapos ang cylindrical, hindi naman siya uniform. And ang spherical lang ang aming highlight since ito yung na-generate pagka nagkakaroon ng seismic wave. Ito yung sinasabing geometric spreading, yung kumbaga ay nakalat niya gaya ng sinabi ni Joyce na yung yung energy kumbaga ikakalat.
Absorption, loss of energy in transmission of radio waves due to dissipation in the ground. Yung absorption dito is when the light hit the surface, it's converted to some other form of energy. Generally, it's going to be heat. Tapos yung reflected dito is parang nagbabounce lang siya dun sa surface. While yung transmitted naman is mas marami siyang nakukuhang energy out of the sunlight itself. Next.
Ito yung absorption.
ito yung absorption na kung saan dito yung sa left side na to. Ito yung parang example nito pag tayo, yung nagsigaw sa parang sa open area, nag-e-echo yung sound. Well, dito naman sa kanan na to, yung sound absorption is parang kahit sumigaw ka dyan, na-absorb nung pader yung pinakang sound. And next.
Itong video na to ay cover lang nito ay yung two factors affecting the na yung attenuation. Pero technically, there are three factors. Ang pangatlo kasi is scattering to be discussed mamaya.
Walang sanggulyo.
Mahina po ba?
Welcome to this lecture video where we will discuss the
Okay na ang sound.
attenuation of science. So the word attenuation just means a decrease in the amplitude of a wave with distance. Okay, so the wave is getting smaller the farther it goes. If you think about an earthquake and how energy is put into the ground in every direction, right? And so when you think about locations on the surface most impacted, assuming you have the same sort of geology everywhere that's going to be impacted by this event, you're going to have the most ground shaking at the epicenter. And then as you get farther away from the epicenter, there's going to be less and less ground shaking until that location is very far away. Humans probably won't even be able to detect that shaking, although maybe it's really highly sensitive as normals might. So why do waves lose energy as they travel through the ground? Well, this is primarily due to two factors. There's a couple other things, but the big two. The first one is called spherical spreading. So remember, energy is spreading out in three dimensions as it traverses through the ground and so what starts out as a whole lot of energy here at the center is supposed to spread out as it goes. So at some time t equals 1, the energy is spread out over this area, and at some time later, t2, it's spread out over a larger area, and even later, it's spread out over this great big area, but it's the same amount of energy as before. So the simple fact that the energy is forced to spread out over a larger area means it's going to have a smaller energy. Just like you order a pizza, the more people you have to share it with, the smaller your slice, right? The more distance you travel, the more space the energy is taking up, so the less energy per unit of space. This is going to decrease the amplitude of our waves. The other thing that happens is that energy is actually absorbed by the ground. So anytime you have the example here, you can even think of it as an analogy of light, right? You might have light coming in, and some of it might be transmitted through a surface, some of it might be absorbed, and some of it might be reflecting. Same thing with seismic waves as they bounce around the surface. The absorption energy, that's actually a conversion of energy from kinetic energy of motion into heat. You've all experienced this. If you've left a piece of metal out in the sun, it's going to be reflecting light waves. That's reflected energy you might see as being very bright. It's going to absorb energy and it's going to heat up that metal. And depending on the metal, it might be able to transmit some light it's not very good at expressing. But hopefully you get the idea. Absorbed by the substrate. If it goes into heating that substrate a tiny bit, um, then we don't have thermometers down there. We can't measure that. It's like in the laboratory. But we do know that it happens, and it's one way that these waves lose some of their energy, aka they decrease amplitude. So in this video, it's showing you a seismic event, and the darkness of the line is representative of the amplitude of those waves. And you can see at this close station here, the amplitude of the wave is very large, but as that wave travels away from the source and its energy is both spread out and attended and absorbed by the ground, the amplitude of that energy along that line decreases, so that here at your next seismic station it shows up with a much smaller. Over here, we're just sort of seeing the same thing. The ground has been sort of rotated, but if you examine the pulse, when it first enters the ground, it has a very large amplitude, and then the farther down it travels, it loses amplitude. So if you were to sort of take a snapshot of that wave at some later time, with a smaller amplitude, and have a smaller amplitude. And here you can see the large amplitude, and then as time goes on, the amplitude is getting smaller and smaller. So that's it. This concludes the video of attenuation of wave energy. This just refers to a decrease in the amplitude of the wave that corresponds to a decrease in the energy of the wave due to the fact that energy is being spread out along the system.
Itong dinidiscuss na itong attenuation of wave energy, ito naman yung sinasabing attenuation relationship. Mamaya na lang natin ipapaka-discuss. Next factor is scattering.
Scattering. A change in direction of motion of a particle because of a collision with another particle. It is an important factor caused by the heterogeneity of the Earth crust and mantle and the availability of hydrocarbon reservoirs. Scattering theories state that rocks containing oil and gas can cause energy attenuation in seismic waves, particularly the high frequency waves passing through them. Dito naman sa scattering, yung mga particles is nagbabanggaan, kaya ano, parang nag-iiba yung mga direction ng bawat isa sa kanila. Next.
And this scattering has 3 types. Ito muna yung scattering, kung mapapansin. Yeah. Pagka 'di ba kanina sinabi na may ang geometric spreading, kasabay ng geometric spreading ang pagkakaroon din ng scattering.
Scattering is different from other types of attenuation since the integrated energy in the total wave field remains constant. Scattering of high frequency seismic wave demonstrate the existence of small scale heterogeneities in the lithosphere. The scattered waves are incoherent since the scatterers are considered to be randomly distributed. Due to incoherence, the phase may be neglected and the scattered wave power in the sum of all the power from each scattered wave. Wave propagation in 2D and 3D in homogeneous medium can reveal various attenuation results depending on what wave field estimates are being utilized. Ito naman yung scattering na to is parang naiiba sa lahat ng scattering kasi ito yung ginagamit as reference para masukat yung 2 2D and 3D dimension na pagkalat ng seismic wave. Next, ito yung formula na ginagamit. K is equal to phi over wavelength. Ka less than 0.01 quasi-homogeneous medium, no significant scattering. Ka less than 0.1 Rayleigh scattering produce apparent Q and anisotropy. Anisotropy 0.01 0.1 less than Ka less than 10 may scattering procedures, strong attenuation and distinguishable scattering in the signal. Yan po yung mga formula na ginagamit.
In addition lang, itong formula na to, pag-identify lang to sa categories ng scattering. Kasi itong quasi-homogeneous na sinasabi, ito yung non-selective scattering, ang Rayleigh or surface scattering and May scattering. Three types of scattering.
So, rinig ba ako? Medyo malakas pa to.
Okay na, okay na.
Okay. Sige, thank you. So, yung first type of scattering ay yung Rayleigh scattering. Occurs when particles are very small compared to the wavelength of the radiation. This could be particles such as small specks of dust or nitrogen and oxygen molecules. Rayleigh scattering causes short wavelengths of energy to be scattered much more than longer wavelengths. Rayleigh scattering is the dominant scattering mechanism in the upper atmosphere. The fact of that the sky appears blue during day is because of this phenomenon. So, para mabigay lang ng konting explanation dito, the sun emits different kinds of light and yung mga iba't ibang color of light has different types of frequencies. Sabi nga dito may low frequency and may high frequency. So, para ma-determine ang mga high frequencies ay makukuha mo sa perspective ng yung Roy G. Biv starting from red, which is the slowest and has the lowest frequency. Then the highest frequency and the fastest frequency, yung mga blue, indigo or violet. So, dito pinapakita yung example ng why the sky appears blue ay yun nga, the much more dominant na frequency na nagba-bounce off dun sa pag once na nag-enter sa ating atmosphere, which is yung atmosphere na yung mas abundant na yun yung nagiging dominant na kung bakit blue ang ating sky. And pagdating naman, let's say, sunset or sunrise, kaya pagdating sa sunset, nakikita natin na mostly red-orange is yung kanyang pinapakita dahil excuse me, dahil pagdating naman sa distance, ang pinakamalayo nakakaabot ay yung may lowest frequency. Dahil either nadedecay ang frequency nadedecay ang high frequency, then yun nga, kaya mostly red or orange ang nakikita natin sa sunset. Then pagkukumpara sorry, may nag-notif. Then pagkukumpara natin sa sunset and sunrise, bakit bihira natin or hindi tayo masyado nakakita ng yellow sky ay orange sky pagdating sa sunrise kumpara sa sunset, dahil magkaiba ang kanilang appearance dahil ang isa ay leaving the sunlight and ang isa ay approaching. Mas mabilis naman yung pag-approach mo kaysa sa pag-leave mo sa sunlight. Pero mostly minsan nakikita rin naman na sa umaga nagkakaroon rin sila ng orange sky. And yun nga. But mostly ang dominant na color pagdating sa sunrise ay yellow, then blue, then gayon. So, the next. Thank you. Then ito naman sa May scattering, occurs when the particles are just about the same size as the wavelength of the radiation. Dust, pollen, smoke, and water vapor are common causes of May scattering, which tend to affect longer wavelengths than those affected by Rayleigh scattering. May scattering occurs mostly in the lower portions of the atmosphere where larger particles are more abundant and dominates when clouds conditions are overcast. So dito naman sa May scattering, more ito nangyayari pag ganyan, pag malapit ito sa lupa or mas lower ng atmosphere dahil madami ang mga molecules or dust na nagtitipon-tipon dito na kung saan makikita natin yung May scattering. Isang example dito ay kung bakit puti ang mga ulap. Kung narinig nyo na yung kay Isaac Newton, yung dispersion of light, if gamit ng triangle prism, kapag ginamit mo ang same triangle prism, then binaliktad mo lang, imbes na i-disperse yung much i-disperse yung light, babaliktad ang mangyayari. Parang ititipon lahat nung dinisperse, then babalik ulit sa kung ano yung original form, which is a white light. Then, yun nga. Imagine nyo na lang sa pagdating sa water molecules, dust molecules, dahil mas malaki and mas denser ang molecules na to kumpara dun sa mga nitrogen or oxygen sa taas. Sinasalo nila at scatter rin naman yung mga different types of frequencies of light, the frequencies, color of light. Kaya kapag sinasama-sama mo rin naman, ang red, from red, then orange, yellow, at iba't iba pa, magiging white rin naman ang kalabasan niyan. Kaya yan yung specific type of May scattering. So, pwedeng next. Yan. Non-selective scattering, the final scattering mechanism of importance is called non-selective scattering. This occurs when the particles are much larger than the wavelength of the radiation. Water droplets and large dust particles can cause this type of scattering. Non-selective scattering gets its name from the fact that all equal wavelengths are scattered about equally. These types of scattering causes fog and clouds to appear white to our eyes because blue, green, and red light are all scattered in approximately equal quantities. Blue, green, and plus red light equals white light. So yun nga. So pagkakaiba naman ito sa unang type ng scattering ay doon sa dalawang types of scattering na sinabi ko nung first part ay ito ay equal and equally distributed ang lahat ng kanilang frequency, types of radiation na binibigay ng light, lahat ay equally distributed, kaya lahat na nakikita natin, which is the rightfully color, yun nga, yung kaya white ang cloud, yung mga nakikita natin ay minsan, ayun nga, parang nakikita natin dahil equally distributed na yan lahat ng frequencies of light, kaya gayon. So, next. So, quality factor. Attenuation is measured by a dimensionless quality known as the rock quality factor Q, or attenuation factor. It is assumed that Q is linked to the physical state of the rock. Q is as ratio of the stored energy to dispersed energy. It measures a relative energy loss per oscillation. Q increases when the density and the velocity of the material increases. In the Earth's crust and mantle, Q ranges from 10 to 1,000. So, yun nga, sabi nga naman daw ang quality factor, ang Q ay ratio. So, yan ay unitless. Yan, ratio nga naman ang pinapakita. Q, pakita dun sa formula sa baba, Q is equivalent to the energy of seismic wave divided by energy loss during one cycle. So, ang kanyang formula ay 2 pi E all over the difference in energy. So, yan, dito papakita yung mga iba't ibang types of rock and yung kanyang quality factor. Bakit ang isa dyan ay may QP and QS? Ang P and S, yan yung papakita ng two different types of seismic waves, yung P waves and S waves. Diyan nagdedepende pagdating sa quality factor if ever nangyari yung gayong klaseng seismic wave. Yan. Then next. Yan. When Q is frequency dependent, this is each frequency loses the same amount of energy per cycle. The situation gets rather complicated. For frequencies up to 1.0 hertz, to the quality factor Q is independent of frequency. Wait lang. For the 1.0 hertz, the quality factor Q is independent of the frequency. As the frequencies increase, Q becomes frequency dependent, and normally Q increases with frequency. The Earth's mantle absorption model reveals that mantle absorption increases at frequencies from about 0.0001 to 1 hertz. A common way to determine Q by getting the amplitude and frequency of the seismic wave at some point during its propagation. Yan. So, yun nga, pinapakita dito na yung kanyang quality factor ay either independent or dependent. Then makikita rin natin dito yung absorption model ng Earth's mantle has frequencies from 0.001 to 1 hertz. So, yan rin yung isang factor pagdating dun kanina sa quality factor na from Earth's crust to Earth's mantle, mga 10 to 1,000. So, itong pagkakaiba sa 0.001 and to 1 hertz, yan lang naman ay isang factor para ma-determine dun sa Q factor niya. So, yung papakita ditong equation is Q of F is equivalent to QO times F squared. So, the general rule will be applied to the seismic attenuation can be written as high frequencies equals to more oscillations to more attenuation. Low frequencies, less oscillation to less attenuation. So, meron pa ata dyan isa pang picture. Pwedeng pamindot lang para, yeah. So, yan, yung pakita na pagdating sa attenuation factor to distance, high attenuation factor to small distances, and pababa na pababa ang attenuation factor sa paglayo. So, iba rin naman pag magpapakita pagdating sa surface waves and body waves. Next po.
Next is attenuation relationship. Attenuation relationship are also known as ground motion prediction equation. A ground motion prediction equation is an equation that calculates seismic ground motion intensity, such as the response spectrum, including the characteristics of the source, path, and site effects. A GMP is constructed by statistical regression analysis of many strong motion records. Ground motion parameters were classified into 4 groups: velocity, acceleration, displacement, and frequency. Ang GMPE ay yun ay mahabang process talaga kasi para kang nagre-research din when you create ground motion prediction equation dahil una, i-collect mo muna yung data or yung mga previous na nangyari na earthquake. Then pagkatapos nun, empirically try statistical fitting that can predict ground motion. Isa-solve nyo pa statistically. Tapos, the more, yung kumbaga, pagdami ng mga na-collect yung data or in-analyze, mas precise talaga yung, yung pag-predict nyo ng ground motion. And, ang ground motion parameters talaga when it comes to, creating ground motion prediction equation ay itong tatlo. PGA, PGV, and SA. PGA is peak ground acceleration, PGV is peak ground velocity, and SA is spectral acceleration. Ito yun. Kung makikita nyo dito sa larawan na ito, ang ginamit lang dito talaga ay PGA. Ito yan, dito, ito yung sa acceleration, ikinumpara sa distance or ang pinaka-formula naman log of PGA is equal to 0.42 m the moment magnitude minus log times the quantity of distance plus 0.025 times 10 raised to 0.42 moment magnitude minus 0.033, distance plus 1.22. Ito yung kaninang sinasabi na yung parameters nga. Una din ay amplitude. Ito yun. Mini-measure din nila ang amplitude tapos inaan din nila sa mga distance, ganun. Sunod ay velocity into distance. Age naman to ng mga yung types of rock kanina. Tapos ang depth naman ay i-measure, ay ikino-compare din sa mga velocity, sa wavelength, ganun. Application of attenuation. Seismic attenuation is in rock is proportional to the frequency. The higher the frequency, more attenuation, and the lower frequency is less attenuation. Q is sensitive to the clay volume, pressure, saturation, and fracture. Therefore, seismic attenuation can be used for lithology discrimination. Dahil doon, ginagamit niya sila sa lithology. The effects of saturation and pore pressure on attenuation is greater on the order of magnitude than the effects of saturation and velocity. Seismic attenuation is powerful attribute that is sensitive to hydrocarbon accumulation, which is ginagamit sa mga petroleum sites. Fluid saturated fractures sa mga sa mga sa radio oceanography or weather radar, and rugosity are the measure of small scale variations of amplitude. Thus, attenuation is extremely useful for reservoir characterization. The ratio of compressional to shear attenuation is applied as hydrocarbon indicator in well logs. QP over QS is greater than 1 indicates less than 1 indicates presence of gas or condensate, while QP over QS minus 1 indicates full water or oil plus water saturation. The upper mantle demonstrates a prevailing shear attenuation, not bulk attenuation. So QP over QS ratios are usually small in partial molten materials. At the same time, rock near their melting point have large VP over BS ratios. VP over BS is greater than 2. Estimates of seismic attenuation combined with VP and VS variation provide information of physical state of the upper mantle and explain the impact of temperature composition and melt friction. Ang VP dito ay velocity lang. Ang Q yung quality factor when it comes to P waves and S waves. Other contributions of attenuation. First is the optical fibers. Dito ay na-discover yung purpose talaga ng optical fibers, which is signal decrease in intensity. Kaya ang plastic fibers, higher attenuation for low range lang. Next is physical oceanography. Ito yung kanina. For weather radar, ginagamit din ang attenuation sa mga ng mga absorption, mga ganun. Sunod ay cancer treatments. Technically hindi lang naman talaga sa sa cancer ang gamit ng attenuation, dahil minsan ginagamit din to sa yung ultrasound pero sa cancer through attenuation na-identify nila yung kung gaano talaga ang kailangan na energy sa pagpa-process or pag-operation, ganun. Computer graphics, ito yung mga pag-i-image lang. Radiography, somewhat related to physical oceanography to. Telecommunication, ito yung talagang makikita dahil yung pagkakaroon ng malakas na signal dito din sa attenuation. And beam attenuation, ito yung sa kailangan natin. Ito yung video.
Kulang sounds pulya.
Wala ba?
Wala.
Mahina. Ready. Ito, rinig na. Rinig na ba yun?
Meron po, medyo mahina.
Oh, mahina pa rin. Wala na.
Yan, okay na. Pwede na.
Tapos karagdagan laang po dito sa kalimutan ko lang. Dito sa GMPs, hindi naman talaga siya formula based eh. Ang sinasabing ground motion prediction equation itong mga line na to. Dahil dito sa bawat line na to, nakaka-create ng equation. Yun lang. Okay na po, sir. Si Joyce yung palaro.
Ay, yung games na po. Ayun, yung games na po. Kung talagang nakinig kayo. Ano, paano na po? Type niyo po sa, ito lang po ilagay niyo sa Google. Kahoot.it. Ito lang sa chat box po.